Good morning, everybody. Thanks for joining us again for another edition of the Building Smart Energy Efficiency Essentials for Modern Homes series, sponsored by DTE and Consumers. We're going to go ahead and just kind of give a quick 1 minute for participants to arrive here to the meeting, and then we will go ahead and get going in earnest. So just give us a quick minute to get started. Okay, we're going to go ahead and get going here today with today's webinar series. We're focused on the Department of Energy, was called the Zero Energy Ready Homes Program up until about 3 weeks ago. But the DOE has changed the name of the program now to the DOE Energy Efficient Homes Program. Not quite sure how I feel about the name change, but it's the same program in essence. And so we're going to be going over this Department of Energy New Homes Energy Efficiency Program today, focused on some of the key elements of the program regarding the building enclosure, HVAC systems, and water heating systems. So if you haven't been hip to our webinar series, we've been doing it just about every week since May. I am Chris McTaggart. I'm the president of Building Efficiency Resources, and I have been a frequent presenter in this series. Thank you to the team from the Midwest Energy Efficiency Alliance, ICF, and DTE and Consumers Energy for having me. My company, BER, focuses on quality assurance and training and education within the residential and multifamily home space. I'm based in the state of Michigan. I live in Detroit and travel all around the state in order to work with our raters that are based here in Michigan, who are working boots on the ground on energy efficient projects all around the state. So as I alluded to, this session is on the DOE Zero Energy Ready Homes Program, but as of less than a month ago, the DOE elected to change the program title to the DOE Efficient New Homes Program. So, on one hand, I am not quite sure about the name. It seems like it's a little bit underwhelming. It's a little bit generic. I think that the concept of zero energy ready homes sounded really good. I think one of the big challenges, and maybe the people who made this decision didn't quite understand, is that the responsibility isn't necessarily to make a building actual net zero to earn this label, but rather it was to basically invest in the building so that, for all intents and purposes, the last step that somebody could take would be to add on-site power production like solar panels at some point. Interestingly enough, what you might assume, which would be that some of these zero energy ready provisions, such as adding conduit and bracing to in the future add solar panels, you might have thought that those would have been taken out of the program, but they weren't. So honestly, the program is, for all intents and purposes, the same as it was when it was called zero energy ready homes. And when it had this kind of cool, colorful badge that one could earn, they just decided to basically take any of the flavor and soul out of the program. And so anyways, it's DOE efficient new homes, but it's the same program. So you may see throughout this presentation where we're still referring to zero energy ready homes. You may see the logo still of zero energy ready homes. You'll have to forgive us because honestly, this change was made pretty quickly. And as you can see, they don't really have much in the way of a logo. DOE efficient new homes, it doesn't exactly roll off the tongue in the same way. It doesn't have quite the same pizzazz. So you'll have to forgive me if I refer to the program occasionally as zero energy ready homes. So jumping into it. So ZERH, zero energy ready homes, AKA the DOE efficient new homes program, has several requirements that build upon the Energy Star Homes program. So the last few weeks, we've been taking a deep dive into what Energy Star is and what makes it unique. And so basically, the DOE program builds on top of Energy Star. And so we're going to talk about just what essentially makes this DOE program different or more advanced compared to the Energy Star program, and specifically building enclosure requirements, HVAC requirements, and water heating. And then next week, we'll be following up with some of the other programmatic requirements as well. So, intro to ZERH. So the program is an initiative by the US DOE. So whereas the Energy Star program is promoted by the EPA, the DOE program comes out of the Department of Energy, but it's kind of the same flavor of a program. This program was sort of created as a reaction to builders who wanted to go beyond Energy Star and how could they earn sort of a label for that. And the essence of what ZERH was supposed to be was, for all intents and purposes, that you could build a home that was as efficient enough to the point where a homeowner would be able to then add renewable energy and be, if not totally net zero, pretty close to net zero at the end of the game. So it's pretty much like creating a home that, from a cost effectiveness standpoint, is cost effective enough to build but deliver an extremely energy efficient home product. And then, the home itself is set up with conduit and bracing in order to accommodate the addition of a residential solar photovoltaic system at some point so that a home could get close to being net zero. So that was the intention behind this program. The history of the program back in the 2000s, when we were in the zone where Energy Star version 2 was very popular. A very significant amount of new homes at that time in the late 2000s were earning the Energy Star New Homes label, but using the version 2 standard of the program. And so in reaction to that, the Department of Energy created the Builders Challenge program that was, again, it was an advanced spec that went beyond Energy Star. So think of it as being a more energy efficient product that earned a badge of recognition by the Department of Energy, basically for builders that elected to pursue a more stringent energy efficiency package. In 2012, kind of at the same time that Energy Star version 3 came out, actually the then chief architect of the Energy Star program switched over to the DOE. His name was Sam Rashkin. And he created the DOE Challenge Home program, which in essence, was version 1 of DOE Zero Energy Ready Homes. It was basically the same thing, but just with a slightly different branding. 2014, they decided that the name Challenge Home, it just didn't sound that good. It's, it sounded like a pain in the neck for builders, not necessarily an advanced building specification. So they decided to rebrand to what really the goal was, which is let's have a label for a builder that builds a home essentially efficient enough to the point where a homeowner could just throw solar panels on top and be pretty close to being net zero, if not all the way to net zero. So that was 2014. And so that was the version 1 of the program. And then here in 2022 to now, we're under version 2 of Zero Energy Ready Homes. So, and obviously now the name has changed here to the DOE Efficient New Homes Program, but in essence, the specification is the same as version 2, DOE Zero Energy Ready Homes. So, long story short, if you're building a brand new home today and you're trying to pursue the DOE program, you would be under version 2, because anything with a permit date as of January 1st, 2024 must use version of the program. So, what makes ZERH? Well, it's kind of similar to Energy Star in terms of qualification criteria. There is a separate single family spec versus multifamily. And it's important to understand that ZERH builds upon the Energy Star program. So you have to be Energy Star certified in order to earn the DOE logo as well. So you have to be at least version 3.2, although there's been re-clarified here that now you can go for Energy Star version 3.3 as well. And it, for single family, is 100% a performance-based program, meaning there is not a prescriptive path. And because we're talking about single family, detached houses, duplexes, and townhomes, there are no common space requirements because this form of construction really doesn't have common space generally. There is a separate multifamily specification that's really for larger multifamily projects. We will be having a whole session that's specific to these multifamily programs, but for today's presentation, I will not focus too much on that. It's good to note that Consumers Energy for 2025 has been running a pilot program that has incentivized builders who selected Zero Energy Ready Homes for application for their projects. So that pilot program has afforded builders participating in it $10,000 for earning the Zero Energy Ready Homes label. And on top of that, you could get the 45L tax credit if you're eligible for it. So up to $15,000 in incentives potentially available if you're in consumers territory and you had already put in your application for participation in this pilot program. That application period is closed now. So unfortunately, if you didn't get in the door before, you're not able to participate going forward, but we'll see what 2026 looks like. Again, the 45L tax credit, which is available for projects that complete as of June 30th, 2026. You could earn up to $5,000 for being DOE Zero Energy Ready Homes certified. So another good thing to keep in mind here as a method to be able to get a little bit of compensation back to the builder for choosing an advanced specification such as Zero Energy Ready Homes. Okay, so how does the program work? Well, the big partners are builders or developers, and then really the raters in the program. You also can become a partner as a designer or architect. But I'd say, especially in the single family realm, we're really talking about builders becoming partners and then raters becoming partners as well. And so Overall, the builder becomes a partner and works with the rater in order to submit the plans and specifications. The rater puts it through modeling software in order to ascertain at the projected phase whether or not the home is projected to earn or meet the program requirements from a performance basis. And then to work with the builder on any of the devil in the details, additional requirements that the program specifies. And then you move to construction phase. And the rater performs on-site verification, inspections, and testing at that point. And on top of that, then the rater has quality assurance oversight by their resident provider. And so finally, at the end of the project, once all the criteria has been demonstrated to be met, the home is able to be labeled as a zero energy ready home. To get signed up with the program, there is an orientation. Raters have to take some trainings, in order to, specifically be able to participate as a HERS rater. And a builder needs to be basically building at least one zero energy ready home every 18 months in order to participate. So the key elements of the program. So again, it's important to understand that it's building upon the Energy Star program. So a lot of the same stuff that goes into Energy Star is of focus here, but there are some specific details that are more germane to zero energy ready homes. So there are enhanced building enclosure requirements for zero energy ready homes, which includes both insulated assemblies as well as high performance window systems. There are specific design and specification criteria for water heating systems, as well as a limitation on where heating and cooling duct systems can live. You can't have ducts outside the building enclosure, except with relatively limited alternatives for how they can be ran in a way that keeps them so that the heating and cooling energy is not lost. There are some requirements for lighting and appliances, and then basically setting up the home to be EV and photovoltaic ready. Doesn't mean that you have to put in car chargers or put in solar panels, but you're setting it up so that the home could accommodate those features at some point in the near future. And then finally, there's a greater focus on indoor air quality through the mandatory labeling of the home as EPA Indoor Air Plus. Okay, so similar to Energy Star homes, zero energy ready homes is a combination of mandatory requirements, meaning that there are checklists that specify certain must do's. You have to do these things. They're not an option, they are mandatory requirements. And then there's performance energy modeling. All of that information is verified by a home energy rater that's specifically trained on the program. And upon completion, then the certification is awarded. So again, zero energy ready homes, it doesn't just stand off on an island, it actually builds upon other federal programs. So you have to meet the Energy Star single family version 3.2 or 3.3 program, and also achieve EPA's Indoor Air Plus program in order to be a zero energy ready home. So both of these EPA-based programs are prerequisites to earn in zero energy ready homes, or now the DOE efficient homes program. So again, let's go ahead and take a deep dive into what this program really means. There's essentially three buckets of what we're trying to accomplish with zero energy ready homes, and which intends to make the product stand apart in the industry as being a more advanced labeling specification. So first and foremost is we're optimizing efficiency, basically building the home in as efficient of a manner as possible, so that really it's cost optimized in getting a very robust building enclosure, high efficiency mechanical and water heating systems, and then some of the better lighting and appliance systems that are available on the marketplace through choosing the Energy Star label for those products. So basically, it's building upon Energy Star, which is already an energy efficiency spec. But again, Energy Star is intending to be about 10 to 15% better than code. Zero Energy Ready Homes is taking that next step. So it intends to deliver even better efficiency, as well as specifically a heightened attention to detail on the building enclosure itself, as well as more specific specifications on things like water heating and cooling systems. In terms of high performance, through having a better building enclosure, as well as optimizing our HVAC distribution system, we're going to ensure better comfort inside the home. And then by selecting the EPA Indoor Air Plus program as a requirement, then the home is ensured to have better indoor air quality. Finally, future readiness. So the idea is that a builder doesn't necessarily have to add things like on-site renewable power, although they certainly could, but you have to set up the project to be able to accommodate this in the future. So setting up the home to be solar photovoltaic ready in the future. Setting up the home to be EV ready. So again, the appropriate amount of power in a garage or dedicated parking space for the home, so that in the future, an EV charger could be added relatively easily. And then finally, heat pump readiness. So both for water heating as well as for space heating, if gas appliances are specified for the home, that's fine. That's allowed. You're allowed to have a gas-fired furnace or boiler for your space heating, or a gas water heater, but there has to be appropriate electrical conduit and wiring that is provided in the space where those mechanicals live. So in the future, you're able to accommodate a transition to a heat pump for both space heating as well as water heating. So that's really the goal of the program, is we're optimizing efficiency. We're making the home sort of have these high performance elements of greater comfort and air quality. There are, from the Indoor Air Plus program, there are some specific water management details to ensure that the home is nice and well buttoned up and it's not going to get wet. And then we're setting up the home to be, potentially meet the technologies of the future at home for consumers. So how does this really shake out in terms of specifications, and how does it compare? Well, the relative HERS scores that one would need in order to achieve compliance with Zero Energy Ready homes, it's likely going to be in the 40s, possibly low 50s for certain plan sets in certain climate locations. But in particular, I would expect that the HERS scores would be in the 40s. And here in Michigan, our average HERS score last year was a 59. So we have a little bit of work to do, but it's still within striking distance for us to be able to consider getting to participating in ZERH from a energy rating score standpoint. Aside from the scores, again, there are mandatory requirements that come out of the programmatic checklists, and so that also has to be met. And we're going to be going over the three of the key buckets of those criteria in today's presentation. So jumping right into kind of bucket number one of these additional requirements, we have building envelope requirements. So for building envelope, we are required using ZERH to achieve insulation levels equivalent to modern energy codes. We are required to have building enclosures that are equivalent to the either 2021 IECC UA level or the 2024 IECC thermal conductance level. Thermal conductance is a little bit different in the 2024 to the UA. It's very similar, but there's a little bit more granular accounting for slab performance, which is why they changed the name to thermal conductance in the 2024. But in essence, if you're familiar with the UA, it's more or less the same calculation. Basically, these higher levels of insulation ensure better comfort, and they ensure that we have the most practical energy efficient design, focused on efficiency and comfort by, optimizing our building enclosure insulation levels. So looking at Michigan and what this would look like, if you're following version 3.2, you'd have to be 100% of the UA of the 2021 IECC. And so we have two tables here. We have the U factors of assemblies, and then we have the equivalent R values. I like to look at these from an R value standpoint just because I think that most people operate more in R values. I think thinking about it in terms of equivalent U factor is tricky because you're looking at the full assembly with drywall and studs and insulation and air films and building sheathing and siding. It's just a lot more goes into the U factor. So just looking at the R values, in essence, we're looking at 0.03 U factor windows. That's not a big deal. We can get there. 0.55 U factor skylights. Again, not a big deal. We can get there. The ceiling R value is R60. That's a bigger deal. And interestingly enough, in the 2024, that was rolled back to R49. What was not rolled back is the wood framed wall R value of being either R20 plus 5 continuous, R13 plus 10 continuous, or R15 continuous in most of these zones. If you get up to climate zone 6, then you'd be R20 continuous as an equivalent value. That's kind of funny how that worked out because the U factor is the same. But regardless, also, alternatively, you could have an R30 2x8 stud cavity, and that would also work as well. Other things, basement walls, R15 continuous or R19 cavity, or R13 plus R5 continuous. And then our slab edges are R10 continuous 4 feet down or under. So that's for the 2021 IECC. And so here's an example looking at this. We've got in the left column, we have our building assembly areas. And then for the center, we have our as proposed home or the to be built home. And then on the right-hand side, we have the 2021 IECC value. And so what we can see here is that we're just basically meeting the requirements. We're a little bit worse on walls. We're a little bit better on ceilings. We're a little bit better on floors. And we're a little bit worse on windows. And we're the same on below grade walls. But when you add them all up using the UA value, we come out to basically being just about spot on. We are meeting the requirements. So that's The beauty of the UA approach is that you don't necessarily have to be exactly the same amount of R value as what comes out of the code tables. There are some trade-offs that are allowed between different building enclosure assemblies. Version 3.3, in Energy Star would allow you to be a reduction potentially in the envelope enclosure efficiency, not dramatically, but you can be up to about 15% worse than the total conductance value from the 2024 IECC. So this is for Energy Star version 3.3. But for ZERH, you have to be exactly the same. So you have to be, there is not the allowance for the trade-off value. You have to be, at least as good as the 2024 IECC. So in this example, we're a little bit worse. And so technically we're not going to be okay for ZERH. We're okay for Energy Star, but not for ZERH if this is our approach. So keep that in mind. The qualification criteria is a little bit different for ZERH compared to that of Energy Star. Okay, jumping into fenestration, there is a specific requirement for fenestration U factors for windows. So most of the state of Michigan is climate zone 5. That would require us to have windows that are at least a 0.30 U factor, but if you had that level, then you'd have to be all the way up to a 0.42 SHGC. Why is that? Well, again, having a higher solar heating coefficient can be beneficial because it brings free heat in. So if you can't get SHGC values that high, then you have to go for lower U factors. So this window sticker that we're showing here shows 0.27 U factor for the windows, and the SHGC is 0.33. This works because we're at least getting that U factor of 0.27. Now, when you get up to northern Michigan and the UP, where you're in climate zone 6 or 7, then the U factor has to be 0.25 or below. And I would just say, from my experience going to get windows on my own house, these levels of performance are achievable in the marketplace without it being punitively expensive. But the idea is that, windows are, if not a one-time investment in a house, you don't really replace them very often. They're going to be around for, 20 plus years in most instances. And so making a better investment in our fenestration to get a better performing product is what the program expects. Moving on to mechanical systems. So those were the two basic key requirements for building enclosure: having better insulation on the total building enclosure, and then having better fenestration systems. You may ask, well, what about air sealing or air tightness or air barriers? Those elements come out of Energy Star. So again, Zero Energy Ready Homes builds upon Energy Star. So all of the Energy Star specific requirements as it pertains to air sealing, air barriers, and then a total building air tightness level, we're pointing to Energy Star for all that. So you have to meet all that coming from Energy Star. There's nothing more in ZERH as it pertains to better air sealing, more air barriers, or a more stringent air tightness limit. So those are all of our envelope-based requirements for the DOA program right there. Better building enclosure and better fenestration system. Okay, for HVAC requirements. Again, there's not as much as you would assume because we're building upon Energy Star. So things like HVAC design, that's already being done as part of Energy Star. Things like the amount of duct tightness, same as Energy Star. So, the duct layout to avoid unnecessary bends and elbows and crimping or crushing of ducts, those all come out of Energy Star. So there is nothing more that is advanced as it pertains to ZERH that as it comes to HVAC systems, except that ducts have to be with inside conditioned space. So that's kind of a bigger deal because, here in the state of Michigan, I would say largely speaking, there is more of an intention to keep ducts inside conditioned space and to not run them in unconditioned zones like an unconditioned crawl space or an unconditioned basement or an unconditioned attic. But occasionally I do see ducts in attics in Michigan. And so the idea here is that, either, say you have a situation where ducts are being run in an attic, either the attic is being encapsulated using, probably spray foam insulation so that the ducts are within inside conditioned space, or alternatively, the builder has to find a different way to keep them inside conditioned space, be that with a truss system that allows for the ducts to stay within conditioned space, or in the case of a two-story home, maybe the ducts live between floors in say an open web floor system or some other type of truss-based system. Alternatively, there is the ability to be able to spray foam over the top of the ducts and then bury them in insulation as an alternate spec. So there are an alternate spec just in case you can't help but put the ducts in the attic. There are alternatives that are allowed. So here's an example of what we're talking about here. So if you have up to 10 feet length of duct outside of the building's air barrier, that's okay. So, we've got this relatively small amount of length of duct. Okay, not that big of a deal. The other option is that you are ducts, but not the air handlers themselves. You have them wrapped in R8 and that the duct leakage is being tested to basically 3% leakage to outdoors. And then they're buried in at least 3.5 inches of blown insulation. So this is another alternate spec that could be used in the case where you just can't help but put the ducts inside of a vented attic. So ducts in floor cavities above unconditioned space, ductwork located within the exterior walls of a building envelope. There are some specific allowances for these types of things. So always check out the programmatic footnotes because I think when you first read the checklist, it just says no ducts outside conditioned space. But then if you go to the footnotes, you'll see there are some specific exemptions that are allowed. But overall, the goal is keeping our thermal distribution system inside conditioned space with, which will essentially ensure that we have close to zero heat loss to outside. And so that all the benefit of those BTUs are going directly for space heating and cooling for the occupants, not losing heat to an interstitial space such as a vented attic. Jump ducts, those are basically transfer ducts that usually are used for pressure balancing bedrooms compared to the main body of the home. Those are okay to be outside of conditioned space, but you have to make sure they're fully buried in insulation and all the joints are sealed, including boot to drywall connections. The other requirement that will pertain to northern Michigan and the Upper Peninsula is that in climate zone 6 through 8, having an ERV or HRV is a requirement. And that ERV or HRV has to be at least 65% sensible recovery efficiency with better than or equal to 1.2 CFM per watt of efficacy. So basically anything in Northern Michigan, climate zone 6, or up in the Upper Peninsula, climate zone 7, you're going to have to put in a balanced heat recovery or energy recovery ventilator. That's a decent performance system. Doesn't necessarily have to be, dramatically leading class, but it has to be a good quality ventilation system. And heck, I would just go as far as to say, personally, I think that this is something that builders should be looking at throughout the entire state of Michigan. I think there's a lot of benefits, both to builders as well as to occupants, to putting in a quality ventilation system. So I would encourage this even if you're in climate zone 5. Any bath fans, so including those that are not a part of your whole house ventilation system. So just for local mechanical exhausts, you have to have them set up to be Energy Star certified bath fans. Why is that? Well, Energy Star certified bath fans are labeled to have lower energy consumption while also being moving a significant quantity of air, such that we have a better chance of meeting our local mechanical exhaust requirements and to do so efficiently. Additionally, there is the benefit that Energy Star bath fans tend to be quieter. And so people will be more inclined to use them when they're not the builder grade fans that tend to be a little bit noisier. So when you're a zero energy ready home project, you have to have better quality bath ventilation throughout the entirety of the house. Okay, so again, those are the mechanical requirements. And again, you might be sort of surprised that they're relatively few. Just to reiterate, we have local mechanical exhaust in bathrooms being Energy Star certified bath fans. We have ERVs or HRVs in climate zones 6 through 8. And then we have some, requirements of ducts being with inside conditioned space with some potential exemptions that are allowed. So, again, not a whole lot of hard requirements for ZERH as a program. And why is that? Well, because the program really points to Energy Star for all the basics. The program points to Energy Star for proper design of heating and cooling systems, so that the loads are calculated properly, so that the systems are sized properly. And then, either track A or B are followed for HVAC commissioning, and we have good quality duct tightness following the Energy Star program as well. So these are just the supplemental specific programmatic elements that come out of the DOE program for HVAC. Not really that much, just a few extra, I think, kind of no-brainer kind of things that make a lot of sense. Okay, we've got, last but not least for today's presentation, we are going to be talking about the ZERH water heating requirements. So the idea behind water heating specific specifications is that when you're making a home with a really robust building enclosure and greater attention to HVAC design, then the next largest slice of the energy pie of a home really is the water heating component. And so in order to drive savings from our water heating end-use load, ZERH incorporates the following specific specifications. Essentially, you have 3 options for how to achieve the programmatic water heating requirements. Option number 1 is having a specifically designed hot water distribution system that limits the amount of hot water waste standing in pipes. So specific volumetric requirements for the actual plumbing design itself. Option number two is to pick certain minimum efficiency values for water heaters, as well as for fixtures, water consuming fixtures like faucets, shower heads, etc. And then option number three is for the home to be labeled under the EPA WaterSense version 2 program. So WaterSense is a whole house water efficiency program that also is promoted by the EPA. And the program itself has some hot water savings criteria. So if the home is certified under WaterSense for the entire home, then that is the other option for meeting ZERH. Okay, so option number one, hot water delivery system design. So this is a option. In my experience, it's not the main one that most people choose, but it is an option. So the idea here is that the plumbing runs from the source of hot water, so the water heater, to the highest volumetric consuming fixture in terms of the stored hot water volume shall have no more than 0.5 gallons of hot water stored. So the idea is it's not always the furthest fixture. Sometimes it's just, whichever one has the largest nominal size. Oftentimes it's the furthest one away. So let's just say, for example, that this is a 2-story home on a conditioned basement. The water heater lives in the basement, and it's positioned more or less in the southeast corner of the home. And then on the second floor, you've got a bathroom that's in the northwest corner of the home. So the plumbing has to potentially, go up 2 floors. And so it's going to be going up potentially, about 20 feet or so vertically in terms of rise. And then, potentially another, say 20 to 40 feet of run. And so you would have potentially, 60 or maybe even more linear feet of plumbing to go from the water heater to that furthest away and potentially highest volumetric fixture. Well, the challenge there is when a homeowner goes to use hot water, it's going to take them a long time to get the hot water to the fixture that they're trying to use. So whether it's their vanity faucet or potentially their shower, it's going to take a long time for it to get there. That promotes water waste. But beyond promoting water waste, the challenge is especially for things like, hand washing. Usually people don't spend that much time washing their hands. So you wasted a lot of water in order to be able to get a very small quantity of hot water for a very short period of time. And then you've got this 60-foot long line, potentially several gallons of water stored within those water pipes. And those are just going to waste their heat into the home. In the summertime, or sorry, in the wintertime, that may be okay because, heat loss off the pipes will just be a form of essentially, useful BTUs for the home. But in the summertime, you actually have to further cool the house in order to make up for that waste heat entering the home. So the idea is, can we engineer our plumbing system to, store relatively little volume of hot water between the source of hot water and fixtures? And you may say, well, that's impossible. It can't be done. No, that's not true. It totally can be done. It just goes down to design. You could choose to have your water heater on the second floor in some type of potentially a central closet, and then it can feed both the bathrooms on the second floor as well as bathrooms in the kitchen on the first floor. And you may be just perfectly fine that way while also having relatively low volume of hot water basically being wasted. So that is an option for meeting ZERH, basically a more thoughtful plumbing design. And the benefit of this is less energy use and less energy waste for hot water, as well as consumers getting their hot water quickly. So I think that that's really beneficial, especially for a builder that wants to sell their home as being advanced or more of a premium. The other option would be to have a recirculation system. But in order to do that, you have to have systems that are essentially demand-based ventilation, or sorry, demand-based hot water recirculation system. So either a push button or a sensor in the bathroom that circulates the hot water sort of, at the demand of the consumer. Alternately, a system that sort of learns and adapts to consumer behavior in order to recirculate water could be useful. Well, that's helpful for people who have a sort of a set schedule. But for people who don't have a set schedule, that may not work as well. So take it, for me, I work from home. I could be taking a shower any day of the week, and potentially just about any time. I'm not very predictable in terms of when I may want to consume hot water. So those adaptive systems, I think they work for some people, but probably not all people. What you cannot use to meet this requirement are either continuous, time, or temperature-based recirculation systems. Those are not permitted to achieve this requirement for water recirculation. Okay, so option number 2, we've got the option of selecting either essentially a tankless gas hot water system or an electric tank heat pump water heater, or a solar water heating system. Those are your options, basically. You have the ability to choose one of 3 of these options. And so, the other element to this is that you have certain low volumetric fixtures that need to be specified in addition to this. And this slide does not actually show that, but it's not just selecting a water heater, but it's also selecting fixtures that are conserving of hot water. So basically, water sense vanities as well as shower heads. And then finally, option number 3 is to have a water sense labeling certification for the entire house. So if the entire home was labeled as a water sense home, that would also be acceptable to meet the water heating criteria for zero energy ready homes. Okay, so here's where this other slide kicked in. Sorry, this is out of order. This goes back to option number 2, that the water heater and fixture criteria. So again, shower heads and then bathroom vanity, sink faucets would have to be water sense. So again, this kicks you back to option number 2. You have to have an efficient water heating system as well as efficient fixtures. Okay, I appreciate everybody's attention to today's presentation, and we're wrapping up here a little bit early, but essentially we went over 3 of the core criteria specific to zero energy ready homes. Again, the mandatory criteria focused on the building envelope, HVAC systems, and water heating systems. During the next presentation, we're going to be focused on the electrification and renewable readiness provisions of the program. So we will be back next week, and we will be able to take a time to focus on those additional elements of the program then. Thank you all for participating in today's series, and we will catch you for the next one.